grandmother. And she's a bit of a Renaissance woman. She likes to do a lot of things. She loves playing sports. She loves baking. And she loves people. Ask anyone that knows her. And if you give her somewhere to be, birthday, wedding, or funeral, she's going to be there. So it was kind of a weird occurrence one day when she forgot her best friend's birthday. And this alone, she's human, she makes mistakes, so this would have been overlooked on its own, but in the days coming, it kind of stayed around and got worse. She kept on having memory problems. And she started feeling dizzy. And she was usually a very productive person, but she couldn't get through any of her tasks without feeling confused and dazed. And, worst of all, she couldn't finish her daily crossword puzzles. Her problem-solving skills just weren't there. So this went on for a while, and eventually she decided that she had to go see a doctor about this. And her and her doctor talked for a while about what might this be, what could happen. So eventually they decided to run some tests, and specifically the test that they ran was a functional magnetic resonating imaging, or an fMRI for short. And this is when she got the bad news. She had Alzheimer's disease. And this is a lot to process, so the doctor broke it down for her like this. Say your brain is like a spider web, right? And a clear, clean, healthy brain. And there's nothing in the way. Here's your spider consciousness. And in a healthy, clean brain, nothing's in the way, it's very transversable, and you can get to different sections of the brain that do different tasks very easily. But when you develop Alzheimer's disease, the clumps of debris start to get in the way of the brain and build up and make it hard to transverse, which thus makes it hard to get to those sections of the brain, which makes those tasks harder and eventually makes the web harder to take care of and maintain, which deteriorates it.
All right, so to go a little more in depth into what Lawson is talking about, we're going to look at how Alzheimer's disease affects the brain. So when Liv's brain was healthy, this is kind of what it looked like. Like Lawson's spiderweb, it was clear, there was nothing in the way. But unlike the spiderweb that Lawson drew, it's not actually made out of spider silk. It's made out of neurons, which are cells that deal with the transmission of information and basically all of your brain functions. Now, for these neurons to function correctly and properly, lots of proteins need to be doing their job. And in Alzheimer's disease, 2 of these proteins have a mutation that causes the disease to develop. And these 2 proteins are amyloid beta and tau. So for starters, the first thing that happens in Alzheimer's disease is a mutation in the enzyme that deconstructs a protein called APP, which is called amyloid beta precursor protein. The enzyme that deconstructs it mutates. So instead of creating amyloid beta 40, it instead creates amyloid beta 42. Now, amyloid beta 42 is not the same thing as amyloid beta. And instead of doing the intended function of amyloid beta, which in a healthy brain regenerates and helps create new neurons and brain cells, it instead just floats around and accumulates outside of the neuron and around the neuron. And this forms clumps called amyloid beta plaques, which are the debris that Lawson was talking about over here. And the way that that messes up your spider of consciousness is it gets in the way of the things in your brain called dendrites. And these dendrites are how your neurons communicate with each other. So as the amyloid beta gets in the way of your dendrites, they're no longer able to effectively send communication between each other. So your neural processes slow down and you experience things like memory loss, dizziness, confusion, and difficulty problem solving. But this formation of amyloid beta plaques is only the beginning of Alzheimer's disease. Typically, the formations begin happening 10 to 20 years before diagnosis occurs. Because the real kicker for Alzheimer's disease is when your tau proteins begin malfunctioning. So, once again, back on a neuron, tau is present in the microtubules of your neuron. So that's another section of the neuron that's important for transmitting nutrients throughout the cell, and also, once again, neuron communication. So because of the amyloid beta, the tau proteins become destabilized, and they begin to actually detach from the microtubule, and they begin to float around, and because tau is a chemically sticky protein, it begins to bind with each other inside of the cell. And because of that, the cell is no longer able to effectively transmit nutrients and neuron transmissions, and the cell begins to die. And this is when Liv starts really experiencing some bad neuron problems and things like memory loss, as cells in her brain begin to die off because they can no longer send signals and send nutrients throughout the cells. And to cite this, we learned about amyloid beta through a study from Dr. Merlin in a study in 2020. Stella's going to talk a little bit more about the treatment options and drug options for Alzheimer's disease.
Okay, so specific to Liv's case, she deals with memory loss, paranoia, and problems with problem solving. So she decided to speak to her doctor about what actions and medications she could take to alleviate the symptoms of her Alzheimer's. So they recommended her 3 things. The first thing is aducanumab, which is a medication that focuses on the amyloid beta plaques that build up in the brain, which Harris mentioned earlier over here. And so as these plaques are building up, the aducanumab binds to these proteins and then triggers an immune response for the brain to clear the proteins. And this is from a research study done by Filio and others in published in 2023. And the second option that he suggested was cholinesterase inhibitors, which focus on giving more acetylcholine in the brain for those who have Alzheimer's, because acetylcholine is important for the communication between nerve cells. So with a higher amount of acetylcholine in the brain, there's an improvement of cognitive function. And then the third one that her doctor recommended was memantine. And this focuses on the overproduction of glutamate in the brain. Because someone with Alzheimer's overproduces glutamate in the brain, which ultimately leads to damaged brain cells and kills these brain cells. So what memantine does is memantine blocks the glutamate from killing the brain cells and improves cognitive function. And this research was done by an institution for quality and effectiveness for healthcare, published in 2020, and this was by the American Society of Healthcare Systems, published in 2016. Now, all of these medications, they're not permanent. They're not permanent. They're just temporary things, and they don't work for everyone. They're also really expensive, and they have a lot of bad side effects, like nausea and vomiting, dizziness, and headaches. So a lot of people, as their Alzheimer's worsens, just like in Liv's case, they tend to go to homes to get 24/7 care for their needs.
As Dylan mentioned, when Grandma Liv's Alzheimer's progresses, she ends up moving into a care facility for people specifically with Alzheimer's that has sunrise to sunset care. These facilities have activities for daily life to fill your time and create comfort for these patients, such as bingo, time outdoors, and book studies or book clubs. But the issue with this is that Grandma Liv doesn't really like bingo. It's not fun, it's not very challenging. While she likes to be outdoors, she doesn't really have a ton of friends because she hasn't found time to connect with all of these patients. And she doesn't really like to read. Along with these, they also don't improve her neuroplasticity or memory recall. Neuroplasticity is the rewiring of the brain through growth and reorganization. And memory recall is the retrieving of memories in the hippocampus or frontal lobe. These problems of not being curated to her specific needs and not being challenging led us to our how might we? How might we design a solution for late stage Alzheimer's patients that improves neuroplasticity through memory recall.
With this problem statement in mind, our team created the Forget-Me-Not. It's an arcade-like neuroplasticity game that helps to improve memory recall. Now, can somebody raise their hand, or everyone, if you have ever played an arcade game and enjoyed it? This is why we chose to go with an arcade game, because many people in these care homes don't enjoy playing bingo all the time or just taking a stroll outside. We decided to create this game. Now, there's a personal user interface which can be specific to Grandma Liv for the hobbies she enjoys, like baking and sports. This arcade game comes with three different games inside. A maze, trivia based on her favorite hobbies, and a matching game. All three of these help to improve cognitive function, such as memory recall. Because, for example, in the maze game, it's directional memory. You're remembering where you had just gone, where you want to go next, where your target is. In the trivia, you're remembering things about your favorite hobbies, even that you used to do when you're a child. And matching games, remembering where the cards were placed and what you're looking for. It also helps to improve neuroplasticity, which Audrey explained there, because as you get
questions, and as you get questions correct or you reach the end goal in a certain amount of time, the next questions or challenge or levels get more challenging, which helps to strengthen and create new neurons in the brain. And with this, Grandma Liv can remember more things her favorite things that she loves to do, and she will feel less of the negative effects of Alzheimer's disease. Thank you.